All right, so we are on the portion where we're not going to use a calculator, and we need to evaluate these logs or these exponentials without using a calculator, okay? So if we have something in logarithmic form, what other format can we take it into? Exponential, right? And if we have something in exponential form, we can take that into what? Log form, right? Okay, so if we're looking at number 6, this log doesn't have a base. What if it doesn't have a number for a base? What was our assumed base? Base of a 10, right? So we can take this log and turn it into exponential form with a base of 10. So can someone, what are we going to write? So 10 to the, yeah, if we set this, say that's equal to x, 10 to the x power is equal to what? Yep, 0.001, right? Okay, so if we look at this, is there a way that we can rewrite 0.001 and maybe a way that will help us see something here? 1 over what? 1 over 1,000? Yep, so we can rewrite that as 1 over 1,000. So 1,000, can we express 1,000 with a base of 10? Right, 1 over 10 to the third, right? So 10 to the x is equal to 1 over 10 to the third. Now again, can we rewrite this in a new way? What is 1 over the 10 to the third rewritten? 10 to the negative third power, right? So if we have negative exponents, that makes us have that flip. 10 to the x equals 10 to the negative third. So if we take, so 10 to the negative third would be 1 over 10 cubed. So that's where that flip comes from. So now we have the same bases. For these expressions to be true, what does x need to be? X needs to be the negative third. Because then you'd have 10 to the negative third equals 10 to the negative third, and we know that is true. Okay? So all we got to do on these, when we see something in log form, we automatically know that we can take that into exponential using a couple fun tricks, right? Okay, so we have this log base 3 of the 4th root of 3. Now again, is there a way that we can rewrite this that will make it maybe more clear to us what's going on? So can we rewrite, how would we rewrite this? So say that a little bit louder. Okay, so you're saying 3 to the 1/4 power. How did you get the 1/4 there? It's what kind of root? It's a 4th root, right? So when we can rewrite radicals with rational exponents. So if we had, say, like the square root of 3, what would that be in exponential form? 1/2. Or if we had a cube root, what would it be? 1/3, right? So depending on like 5th root, 4th root, that denominator number is where you get that from the radical, okay? So now we have this, what does x need to be if we can see it from here? X has to be 1/4. Would there be another way that we could have solved this, maybe without rewriting it into exponential form? Just starting from, if we started from our log, just can we change, what would happen, I guess, let me ask you this, if we changed log of a base 3, if we made this, if we changed this to that 3 to the 1/4? Right, so where can we put that 1/4 using our properties? So we can move that exponent out front, right? So we'd get 1/4 log base 3 of 3. And what is log base 3 of 3? 1, right? So it would be 1/4 times 1, and that again is 1/4. Okay? So there's a couple ways you can do that. Both approaches are fine. You're going to get the same answer, but whatever you need to see, maybe it'll be a little bit easier on you. So lastly, log base 64 of 4 is equal to x. What can we do with this one? So we can take it into exponential form, exactly, and rewrite it as 64 to the x power is equal to 4. So can we rewrite 64 now with a base of 3? I mean, not a base of 3, a base of 4, I'm sorry. So 64 is 4 to what power? Third power, right? So we're just going to replace 64 with 4 to the third. We keep that to the x power is equal to 4, right? So now what can we do with that left side to simplify it further? So it's going to be 4 to what power? 3x, right? So when we have powers to a power, we can multiply those together. So we get 4 to the 3x equals 4. So now, what power does that 4 have, even though it's not written there? 1, right? So what does x need to be? Right, so we can say 3x is equal to 1, x is equal to 1/3. And if you see that, oh, I know 64 is that, I know it's to the third power will give me 64. I know that if I took the cube root of that, that'll give me 4. Then I could say you could just jump to the 1/3 if you saw that. If not, this is a great approach. Okay? Do you have any questions on these three here? We're all set? Because I know you guys were saying that the backside and these last few problems were the most difficult, I think. I've heard from most hours. Is that true? Everything was difficult? All right. Okay, so we have this e. Now we're working with e, right? We have e to the ln x squared power. So what form is this in? What type of problem? What type of exponential, right? So we know that we can take it into log form, and then since we're using e, we're going to use natural log along the way. So I'm going to say, since this already has an x in it with the power, I'm going to say this is equal to, I'm going to say it's equal to w, okay? So don't write, you don't want to introduce a new variable that's already in there. So if you set it equal to x, you're going to get 2 x's on both sides eventually, and that's going to cause some confusion. You follow me? It's the same thing like if we wrote this as y e to the ln x squared, you wouldn't say x is equal to e to the ln x squared, right? So I just picked w. We can call it y. That's fine. We'll say y. Make it e. Okay? So now how would we want to write this in log form? So the base in our exponential becomes our base in our log. And then logs are always equal to an exponent. Logs give out an exponent, so whatever we have in our exponent of our exponential is what we're equal to in our log. Okay? So now we have this with a log of a base e. Is there a way that we have an ln in there, right? We see that ln of x squared. Is there a way that we can get an ln on the other side as well? Okay, how would we do that? Log base e is equivalent to ln, so we can make that replacement. So natural log of y is equal to the natural log of x squared. So now that we have a natural log of y equals natural log of x squared, we have natural logs on both sides. So for this to be true, this expression to be true, what does y need to be? X squared. Because then we would have natural log of x squared equals natural log of x squared, and no matter what x is, that's true. Okay? So I know it's kind of different using your variable as an answer, but this is good too. Any questions on that? Again, it's key that we can go from exponential form to logarithmic and make that replacement with natural log and log base e. Okay? So we have this, number 10 here, we have the natural log of the square root of e. So let's rewrite this in another form. How can we write this? How can we modify that square root of e? So it's natural log of e to the 1/2, right? And then we can make that natural log replacement with log of base e, right? So now we have this log base e of e to the 1/2. Similar to what we did earlier, how can we move this 1/2 out of there? Put it in front, right? And that's beneficial because we know that log base e of e is what? 1. So anything, same base, as what you're taking the log of, that's always going to be 1, even if it's, e or 5s and 5s, whatever it is, as long as they're the same, that's what we're going to get out. So if we set this equal to x, x is equal to 1/2, because this is 1. Okay? Any questions on that? All right. So we have log base 2 of 0. Let's say that's equal to x. How should we go about this one? We're going to put this in exponential form. Okay, so what would it be then? 2 to the x power is equal to 0. Okay, so now what? So we can't. Why can't we do anything? So there's no value for x that we could pick that would give us a 0 out, right? So if we think back to what logs and natural logs are defined for, what were the restrictions for that? What could we not plug into a natural log or a log? 0. Anything else? Negative numbers, right? Logs were only defined for positive values of x, right? You could get a 0 or a negative number out, right? Because our range was what? We talked about that when we graphed them the other day. Right. Negative infinity to positive infinity, all real numbers, right? And we said our domain, it had to be a positive value for x. So we can only put in positive numbers, but we can get out negatives. So be careful of that. So if you see like the log of 0, then you can automatically say, all right, no solution. And if you don't see that, if you're like, okay, what do I do? If you put this into exponential form, you can see that you won't be able to pick a number for x to get that equal 0. A couple ways to disprove this one. And if you're lucky enough to be using a calculator in this type of problem, if you type log of 0 in, you'll get an error or no real solution. Questions? All right. Number 12. How could we work with this? We have a log base 4 of 64. Does anybody know what log base 4 of 64 is? So logs ask the question, 4 to what power is 64? Your answer would be 3, right? So we can just take this log base 4 of 64, and we know that's equal to 3. So now it just becomes a 4 plus 3 problem. What's that? A nice 7, right? Are you kicking yourself because you didn't do that in the partner test? Okay, so now if we look at number 13, let's do some rewriting first and maybe see if that will help us, okay? So what can we do with that 2 that's out front? We can put it as an exponent of which number? 5, right? So we get log of 5 squared plus the log of 4, right? So what is 5 squared? 25. So we have log of 25 plus log of 4. Now, if we know that if we have multiple logs that are being combined with addition or or subtraction, we can combine them somehow into one log, right? Addition means multiplication, so it's going to be log of what? Log of 100. So now we just need to figure out what log of 100 is. Well, what is our base here? 10, right? We have a base of 10, so our answer will be 2. 10 squared equal to 100. So x is 2. All right. So now let's look at 14. So again, can we rewrite this in a way that will be beneficial to us? So we can do what? So we can get the log base 3 of 6 squared minus the log base 3 of 4. So what is 6 squared? 36, right? Now we have this log base 3 of 36 and this log base 3 of 4. We have the same bases there, so we can combine them how? With what operation? Division, right? So we would get log base 3 of 36 divided by 4, right? So what is 36 divided by 4? 9. So what is log base 3 of 9 evaluated? So 2. 3 to what power is 9? That answer would be 2. We good? All right. Okay. So we want to write, we have multiple logs here, right? And we want to now write them as a single expression using our properties, okay? So we have a combination here. We got it all. We got the numbers out front, we got addition, and we got subtraction. So we really got to be careful that we do things in the proper order. So let's first take care of these numbers out front. How can we do that? So where do they go? That's right. So they come our exponents. So we're going to get log of x squared minus the log of x cubed plus the log of y to the 4th, right? Okay, so we have to be careful here with the subtraction. The subtraction is only being applied to which log? X to the 3rd power, right? Now this y, this log of y to the 4th is being added. So it's not being subtracted, it's not part of that. So we can use, do you guys remember that if you have like things that are being added or subtracted, you can move them around in any order? We can use that. Anybody remember what that property is called? Associative, commutative, remember those properties? Associative? Okay. So you can associate with anybody, right? You can move around. So we can move things around. So we can move this addition to go with our x squared, right? So log of x squared plus the log of y to the 4th minus the log of x cubed. So the only thing that's being subtracted is that x cubed. So this is why it's helpful to move that around. So now we know that what's being added and what's only being subtracted. Now how do we combine these together into one log? We got the addition, that's what? Multiplication. And we have subtraction, which is division. So we can combine them two together, and we would get log of x squared y to the 4th, and then divide by the x cubed. So lastly, is there a way that we can simplify this further? How would we do that? So we would get, yep, we can cancel out this 2x's here with 2 of them down there, and we would get log of y to the 4th over x. Okay? Any questions on that? Okay, so what we want to do here is let's first break everything apart to see what we have and see if we can do some simplifying there, and then bring it together. Because we got natural logs here, and we got some natural logs with e involved. So I'm going to throw a parenthesis around this e so we know that that 4 is just being subtracted off at the end. Okay? It's not included with that natural log. I don't know if that might have been unclear, but I think we'll make sure that's clear on the test for tomorrow. So how would we break the natural log of ex apart into what? Addition, right? So since we're multiplying in here, we can use that property and break it up into addition with multiple natural logs. So we broke that up. What about this 3 ln with the base of e, or ln of e? So we can bring that 3 up to its power, right? So we'd get ln of e cubed and then subtract 4 on the end, right? So now we've got it all broken apart, and let's see if we can simplify some things here. Natural log is the same thing as what? Log of a base e. So if we made these changes here, say we had log base e of e plus log base e of x plus the log base e of e cubed minus 4, do we see anything that we can rewrite now? What is log base e of e? 1. So we would have 1 plus the log base e of x, because we can't do anything there. We have that variable x. Now what about that log base e of e cubed? Now, how is this and that different? We have that exponent, right? So log base e of e will be 1, but that 3 has to come. We can put it back out front, right? So what would this be? So this is going to be a positive 3. Then we subtract 4 off, right? So again, the log base e of e cubed is the same thing as 3 log base e of e. And that's where we get that 3 times 1. That's why that's 3. So now, how can we finish this one off? So we have 1. We can move this around again. 1 plus 3 minus 4 plus the log base e of x. So what's 1 plus 3 minus 4? 0. So then we'd get 0 plus a log base e of x. Now can we rewrite that a little bit simpler? So our final answer is going to be the natural log of x. Okay? Question? So log of base e of e to the third, right? We have this exponent here, and we can take that out, right? We can move it out front. So then we would just have that log base e of e again, and that's going to be 1. 3 times 1 gives us the 3. Make sense? So if it might help to break a problem down to its simplest parts and see that some things will simplify out, okay? And then use our properties the right way, okay? So let's move on down here. Now we just need to solve these equations for x, right? And it says to check for extraneous solutions. Extraneous meaning what? So if we plug it back in, we're going to get some sort of error with it, right? We've got to toss that one out. So we have this 3 to the x minus 2 equals 79. What should we do first? Add 2 to both sides. We want to isolate our exponential or isolate our logs, right? So this is an exponential form. We can take it into log form, or we can get a same base, perhaps. Can we get a same base here? So what is 81? 3 to what power? 3 to the 4th power. So now 3 to the x is equal to 3 to the 4th. What does x need to be? 4. And if you see that at step 1, I know that I just have to raise 3 to 4 for 4th power to get 81. That's okay too. No, if you can get it from here and you can say, okay, I can go to that 4th power, then good. But the more work you show me, and more work you show me and Miss Audia, the more we know you understand. And if there's like a calculation error, then we can, award you for getting, just, you punch something in the calculator wrong. So if you don't, so say you just say you said x was 3, just because you thought, oh, I know 3, yeah, and you just made that error, we got to penalize you for that. But if you show this work, then the more you give us, the more we can give you. Make sense? Okay. So let's look at this one now. We have 4 to the x squared minus 1 is equal to 8x. So there's a couple things we can do here, right? We can try to see if we can get these in the same base. We can apply logs to this. So what can we do here? I think the more simpler approach is getting a same base. So can we get a same base here? And what would that base be? 2, right? So 2 to what power is 4? 2 squared is 4. And just make sure you keep that other power included, because you have to make that multiplication eventually. So now what's going to be our right side? 2 to what power is 8? 2 to the 3rd power, right? So you're just replacing those numbers there with the proper base and the proper power. Don't change anything else. So now we can rewrite these. We have a power to a power, so we just multiply. So it's going to be 2 to what power? 2x squared minus 2. Make sure you distribute that 2 through. And that's going to be equal to 2 to the 3x, right? So we have the same base. So for now, for this expression to be true, what needs to be set equal to each other? Right, take your exponents and set those equal to each other and solve. So we get 2x squared minus 2 is equal to 3x. So what type of an equation do we have here? What type? It's a quadratic, right? Right, so to solve quadratics, we need to set them equal to 0, and then we can factor that out. And hopefully, it works out, or we can use, if it doesn't factor, what can we use? Quadratic formula. So it's going to be 2x squared minus 3x minus 2 is equal to 0, right? So what does this factor out to? We got to play with that 2 out front. Say that louder. 2x plus 1 and x minus 2. Because it would be 2x times a negative 2, which would give us a negative 4. 1 times x would give us 1. So it multiplies together to give us the negative 2, adds to give us negative 3x. So yes, that does work. So now we do what? Set them equal to 0, solve for x, right? So x is going to be 2x plus 1 equals 0. X is going to be a negative 1/2. And x is going to be positive 2. So we've got two answers out here, right? We need to make sure that these both work. So we can plug them back in, and we're not going to have any issues, right? When will we have an issue when we're checking our answer? If we plug them back into a log and we get what type of out? If we have logs of negative numbers or logs of 0, right? Those are the ones we need to look out for. But if we definitely were to check these answers in, we will get the same on both sides. We'll see that those are equal, okay? So on the test tomorrow, if you have extra time, check your answers. Plug them back in. So now we have log of 4x equals 2. What's our base here? 10, right? So how can we rewrite this log into exponential form? It's in log form, right? So I'll write the 10 in there. We have a log with a base of 10 of 4x is equal to 2, right? So we have this log here. We can take it into exponential form. How would we do that? It's in log form, right, Steve? So we want to take it into exponential form. So what's our base, Steve? 10, right? So it's going to be 10 to some power. What power? Follow me? Now it's equal to 4x. So what's 10 squared? 100 is equal to 4x. What's x going to be? X is equal to 25. Not bad? We're okay? I think you guys got freaked out with the length of this partner test and the time, and yeah, I think that kind of happened. So just take things down to their most simple cases. Is this an exponential or is this in log? If it's in log, I can take it to exponential every time. If it's an exponential, I can take it to log every time. Now, if there's an e involved, I know that I can replace log base e with ln. So if you take things down to this most simplest case, that's a good place to start. As soon as possible. So if you want to stay for the finish, that's good. If not, you can go if you have to for that. All right. So we're looking at these now. So we're adding in some extra parts, but it's still that same idea of going from log to exponential, exponential to log. So we have this in log form, right? What's our base? 2. So if we write this in exponential form, we're going to have a base of 2 to what power? Equals 2x minus 4, right? 2 to the 4th is what? 16. So 16 is equal to 2x minus 4. Add 4, we get 20 is equal to 2x. Divide by 2, x is equal to 10. So since we're dealing with logs, we need to make sure that the value we get out for x doesn't give us a log of 0 or a log of a negative number. So we plug 10 back in, are we okay? We're all right. And log base 2 of 16 is definitely 4. So we know that 10's good. We checked it. We're in the clear. So we're in log form again, but now we have multiple logs here. So we're looking at this, and I'm like, I want to take this in exponential form. I want to get there. But for right now, I can't. I got multiple logs. I need to get to one log. Right, so we can combine these using those properties into one log. So since we're adding, we need to multiply together. So we'd get log base 6 of 4x is equal to 2. So we got in log form. Let's take it in exponential. What's our base? 6, so it's going to be 6 to what power? That's right. What's 6 squared? 36 equals 4x. What's x? Divide by 4, x is 9. You guys kicking yourself yet? Well, see, here's the good thing, though, right? You'll ace the test tomorrow. We'll replace that lower partner test score. Everything's good, right? So now we got natural logs. Same things apply. Okay? But now we have a case where we have natural logs on both sides, right? What was nice about that? Do you remember? Let's take this and we'll see when we get there. So how would we combine these natural logs together? We want to get them one down. So it's going to be a natural log of what? So we're subtracting in between. So if we are subtracting, we want to combine in one with what operation? Division, right? So we're going to take the first and divide by the second. X minus 6 over 2. What's the right side? ln of what? X minus 4 divided by 3. So same idea. So if we look at this, we have natural logs on both sides of our equal sign. For this to be true, what do we just need to set equal to each other? What's in our parentheses, right? So if we get logs of the same base and natural logs on both sides, we can just take what's in our parentheses, set it equal to each other, and solve for x, right? Now we have to be careful, though. The difference between 22 and 21. 21, we cannot just drop our logs and say x plus 4 is equal to 2. It's only the situation where you have logs on both sides of the equal sign, or natural logs on both sides of the equal sign, okay? And they have to be the same base, exactly. So now we can just take x minus 6 over 2 is equal to x minus 4 over 3. So how do we solve this type of problem? Right, so we can multiply by 2 over here to get rid of that one, and then multiply by 3 over here, right? But what we do to one side, we do to the other. So, yeah, cross multiply. That's simpler. So, not to confuse. No, that's my fault. So we would have, what would we have? We'd have 3 times x minus 6. What's that? 3x minus 18. And what's that equal to? 2x minus 8. That's much simpler. So now we want to solve for x. What do? Subtract 2x, add 18. X is equal to 10. So again, we're working with natural logs and logs. We need to make sure that the answer we get out is okay when we plug it back in. It's not going to give us 0 or a negative. And we're okay, right? 10 minus 6 is a positive 4. 10 minus 4 is positive 6. And we were to combine those together, we would see that we would have what we want on both sides. Okay? So now let's take a look at 23. We're doing okay so far? Good on time? Awesome. So again, we got logs on both sides. So we're hoping that we can have the same bases. We can make that almost like that cancellation. We can just take what's in our parentheses. But we got 2 logs on one side, right? Right, so we need to condense those down. Since we're adding, we can combine them with multiplication. So log base 4 of x times x minus 2 equals log base 4 of 8. So now we can just say, okay, I can take what's in my parentheses and say, okay, set them equal to each other, solve for x. So we need to do what with this, though? Distribute that x through, right? X squared minus 2x is equal to 8. What type of equation do we have? Quadratic, and we can hopefully do what? Factor it, and we need to first set it equal to 0. So get everything on one side, 2x squared. So did this factor? What does it factor out to? X minus 4, x plus 2 is equal to 0. What are our final answers? X is equal to 4, x is equal to -2. So we got that out. We worked our math out. Everything's looking great. But now we need to check to make sure that both of these answers will work. So does the 4 work? 4, we got log base 4 of 4 plus log base 4 minus 2 is 2. That's okay. No issues there. That's going to work out. Now if we put that -2 back in, do we have an issue? Right. We have a log base 4 of a -2. Now we can't take logs of negative numbers. So we got to toss that one out. It's extraneous. So our final answer is going to be x is equal to 4. Now you have to be careful. Just because you get a negative number as a solution, that does not mean automatically that you can throw it away. It is a good indicator that your number is not going to work because it's negative, but you need to check both. Because there could be situations where you put a negative number in and it still works. So you have to be careful, all right? So don't automatically assume. All right, lastly, these last two. Now we have a similar situation, but we have subtraction now on that left side. How do we combine those? Right, so we're going to have log base 3, 15 over x equals the log base 3. So now we can take and set them equal to each other, right? So what's going to be equal to what? What is x going to be? So we can get that x out of there. We get 15 equals 3x. X is equal to 5. Good? All right, lastly, we have a natural log here, right? So look, it's equal to 0. So I can just say, all right, no solution, right? I'm done. Wash my hands. No, right? It's only natural logs of 0. If that 0 was plugged in. So we got to be careful. Don't make those assumptions. So how are we going to deal with this one? We can't just drop that natural log out, right? We don't have natural logs on both sides. So what can we do? We can do this replacement first, right? We can always rewrite this with a log base e, x plus 5 is equal to 0. So now we have this a nice log here. We can take it into what form? Exponential. Fantastic. So it's going to be a base of what? E to what power? X plus 5. What's anything to the 0 power? 1. So we have 1 equals x plus 5. So x is equal to -4. Hold up, we got to check it. Does it work? Yes. It gives us a natural log of 1. So that's in a situation where we got a negative number out, but it still works. Okay, so we got to be careful. We got to make sure we check. All right, so that's everything we needed for our partner test.